Hello, today we are talking about the vectors, and it is a very important chapter related to the competitive exams also, and it is a very important topic related to physics, and we will explain here key concepts and a lot of practice questions we will do after there. Okay, so before starting the vectors, it is very important to understand the physical quantities. There are two types of physical quantities here on the basis of their magnitude and the directions. Scalar quantity and the vector quantity. You're looking here. It has only magnitude. What do you mean about the magnitude? Magnitude is just the amount of matter. The example of a scalar quantity is mass, temperature. The amount is also, you can say, that is number, and the speed and the distance and the density. These are the example of scalar quantities, etc, etc. Okay, and what about the vector quantity? A vector quantity, it has magnitude with the direction. What is the meaning of this line? With the change of direction, magnitude will change of these quantities. The magnitude of these quantities change with the direction. We are writing here the examples of vector quantities. It is weight and velocity. I hope you are familiar with these, and the displacement and the force and etc, etc. So these are the vector quantities. Now we are explaining here how the direction change. We explain that is distance is scalar quantity, so it is scalar, mean direction doesn't matter here. Okay, and only the magnitude. So you look the distance from A to B point and from B to C point, the direction is same. That AB and BC both distances are parallel to the plane, 10 kilometer, and BC also 10 kilometer. So a boy start walk from the point A and reach B, and from B to C. So how much total distance is covered? So that is, the answer is 20 kilometer area. Like this, AB plus BC is equals to 10 plus 10, that is 20 kilometer. In the second case, from A to B and B to C, if the direction of BC is changed here, the BC is perpendicular to the AB, and AB is 10 kilometer here, and the BC also is 10 kilometer, and the boy start walk from point A and reach B, and from B to the C. So the distance here, simply we can add here like AB plus BC, that is 10 plus 10, and we can say that the total distance by boy is covered, that is 20 kilometer. I hope you understand. And similarly, in the third case, boy from reaching from A to B point, covering the 10 kilometer distance, and then returning from B to A point, 10 kilometer. So the distance is, now we are adding here like A to B and B to A, that is 10 plus 10. So in three cases, you're looking clearly, the distance remains same, there is no matter the direction is changed. In all the cases, the distance remains same. What about the displacement? Is you're looking A to B, B to C. Here is 10 kilometer, and this distance BC also 10 kilometer. A boy start walking from the point A and reach the final destination at C. The displacement is said to be the distance between the starting point and the final point. That is the straight line from the initial and the final destination. So you're looking, displacement is AC. That is very clearly understand here, that is 20 kilometer. Now in the second case, A to B and B to C, the 3 points, and covering the boy these distance 10 kilometer from A to B parallelly and from B to C perpendicularly, and the displacement in this case is AC. How can we find the displacement here? Using the Pythagoras theorem. I hope you're familiar with this. So it is hypotenuse AC. We are evaluating the value of AC here, like square of 10 kilometer plus square of 10 kilometer, like this. So AC is equals to under root 2 into 100. So the value is 10 root 2 kilometer. So you clearly visible here in the second case, the displacement change with the change direction, and the magnitude of the displacement change here, that is 10 root 2 kilometer, not 20. Okay, and you are looking here for the third case, that is from A to C, A to B, and B to C. Boy went from A to B and then came back from B to C. The displacement is here 0. I hope you understand this one. So in the third case, you are looking clearly the displacement, because the final destination and the initial destination at the same point, so displacement is 0. So it is very clear. I hope you understand about the scalar quantity and vector quantities, how the direction is changed, the magnitude of the quantity, and the scalar quantity remains same no matter what the direction is. I hope you understand this one. Now we are moving for the next one.